Hello. This is going to be a video overview of a script I made for my brother. My brother is a student getting his PhD in neuroscience. Part of his research is involving these hamsters, as you can see here, and studying the certain activities they do under specific emotions. So to do that, what he does is he gets these hamsters familiar with these habitats, we'll call them. So he'll have this hamster associate this habitat and this zone in the side of this habitat as the area where he can get food, the area he's always kind of placed in to start, and then kind of an area without food. So what he'll do is he will then take these hamsters, provoke an emotional state out of the hamster. He's told me stress is the one of big study. So he'll stress the hamsters out. Or get them into a stress state, and then place them into these habitats. And as you can see, hamster kind of walks around and wanders, and he wants to study what the hamster is doing. He knows this hamster has the association that up here is food, no food, and kind of the entry area where he gets entered into this habitat. So over this 10-minute clip, you can see the hamster just wanders around. But we need to quantitatively know when and where this hamster was spending its time. So I went ahead and made a program to try and aid with that. So we'll go ahead and run that now. It's just Python script using OpenCV for the background subtraction. And we'll just go ahead and run through it. First thing it does, you saw prompts for the directory of the video. And then we have some instructions here in the bottom left of the console. So we need to define the zones. So I'll just do zone 1, just click and drag. You can right click if you didn't like the zone, draw it again. But we'll go ahead and define zone 1, zone 2, zone 3, and then zone 4. So like we said earlier, each of these zones has kind of predefined associations to the hamster. So we've gone ahead, defined our zones. So I'm going to go ahead and hit enter. To move forward per the console. This is the kind of a value we've been playing with to try to hone in on some proper settings. This is just the sensitivity is actually just the contour size of the blob. But we've been using actually 200, so I'll go ahead and enter that. Not showing video playback can speed it up a little bit. I didn't know how many it was doing, so I made it an option, but for this, we'll absolutely show the video. And since we are going to show the video, we need to choose the starting frame. And you can see here, he usually has these starting or info cards at the start of the video. So we can just go ahead and hit N to go 1 second forward in time. And we can find the actual first frame that we want to start. So I'm going to go ahead and hit S and actually start the analysis here. And we'll get a better idea of what it's doing. So you can see, it just draws a little bounding box over the hamster or the moving object in the frame. This is using OpenCV for background subtraction, which tries to create a known background, a known static area of the image, and then compares the current frame to that known static one, and the pixels that are different are the objects. This is a very rough outline of the background subtractions. I'm by no means a programmer, but that brings me to one of the points I wanted to discuss and point out was the use that I had, or an example I had of using ChatGPT. I was at a point in the video where I was getting the background subtraction working on the hamster, but I needed to do all the zone analysis. I needed to know what zone he was in. And we can see we can even have nested zones. So I had just kind of written out in plain English here a little bit of kind of mathematical talk, but more so just plain English of what my problem was. And I was actually able to just drop that pretty much directly into GPT and have it spit out very functional and very usable code. That specifically accomplished what I was looking for. And I'm by no means a programmer, so programmatically this is pretty simple, but it was really cool to me to be able to think in terms of the problem rather than in terms of the code. So that's just a little shout out that I wanted to give. I thought it was really neat. But yeah, this is just going to go through and analyze every single frame of the video and start to record its positions, and then we'll go ahead and check out the output that it does. It ends up doing a CSV file. Just writing this one now. We'll go ahead and go to a pre-opened one or pre-compiled one, but it's just a CSV of the time in the video and its X coordinate system, location, and the Y coordinate system of the centroid of that smallest bounding rectangle, and then it'll say what zone it was in. Small note on the coordinate system for vision applications, they all seem to be the top left. You can find out why here. I don't really follow, but for vision, 0, 0 is the top left. I found that interesting. But yeah, we end up with the coordinate system and the zone and time. And with that, I made another program just to go along with it to kind of spit out some relevant information. So we'll go ahead and run that for demonstration's sake. And it just generates a ton of plots here. Some he didn't ask for, some not helpful. This one was just a little timeline view. I thought it was neat, but not very information rich. This was the kind of the main one of interest, where the hamster is spending his time. So a simple time zone or timeline type view, cumulative time in each zone over time, just a total sum, heat map of where he was spending his time, and then again just location over time. This project was just for fun, but I'm going to throw everything up on GitHub. I'll throw a link to one of my brother's publications as well if you're interested in that. But yeah, that's all I got. Thanks.